Hello, my name is Siddharaj Bhatta, uh, and in this video I'll discuss about the percentage problems on the quantitative section of GRE. So again, you can contact me at this email address if you have any questions. So before discussing the percentage problems, let us explain or let us be aware of some key ideas. The first key idea is A% of B is always equal to B% of A. For example, 20% of 10 is always equal to 10% of 20. So this can be extended to 3, 4 and 5 numbers also. For example, 500% of 200% of 100 is 100% of 500% of 200. So I mean, so long as these three numbers are here too, flipping the numbers before or after does not matter. So with this key idea, we can solve the percentage problem in the exam in a quick second. For example, this is a quantitative comparison question. Sorry, this must be quantity B, and this must be 23 over 25. 25 this must be. So quantity A is 11 by 19% of 23 by 25. So this is A% of B. This is 23 by 25% of 11 by 90. So this is B% of A. So this quantity must be equal, and so our answer must be C. Key idea 2. So this is related to finding the new quantity after a percent increase. If a quantity is increased by T%, to get the new quantity, we multiply the original quantity by 1 plus T over 100. For example, if gas bill is increased by 20% from 1200, the new quantity will be 1200 into 1.2. So then 1.2 has appeared here from 1 plus percent increase is 20 divided by 100, so which is equals to 1.2. so if the percent is increased 30%, we multiply by 1.3. If the percent increases 50%, we multiply here by 1.5. So as a second example, 5% tax levied on a $40 t-shirt. The new price will be 40 into 1.05 equals to $42. So you can multiply these two numbers on the on-screen calculator if these numbers are in decimals. Now we go to key idea 3. So this refers to finding new quantity after a percent decrease. So following the same logic, to find the number after a certain percent reduction, we multiply the original quantity by 1 minus T over 100. For example, gas bill decreased by 20% from 1200. The new bill will be 1200 into 0.8. So this 0.8 has come from 1 minus 20% decrease divided by 100. So if the reduction is 30%, 0.7 will appear here. If the reduction is 60%, 0.4 will appear here. So as a second example, 15% discount given on a $40 t-shirt. So the new price will be $40 into 0.85. So this 0.85 is 1 minus 15% over 100. So the discounted price will be $34. So now we move to the next idea, which is finding the original quantity from new quantity in case of percent increase. So if a quantity is increased by t% and we know the new quantity, divide the new quantity by 1 plus t over 100 to get the original quantity. For example, the markup price of a short was increased by 20% and it is now $500. What was the original markup price? So to get the original markup price, we divide 500 by 1.2. So this 1.2 has again appeared from 1 plus 20% divided, 1 plus 20 divided by 100. So the original markup price was 416.67. So you can divide this on the on-screen calculator in the exam. So the next example is about successive percent increases. The price of a coffee after a 5% service charge and the 10% tax is $5. What was the price in the menu excluding such charges and taxes? So in this case, we should divide 5 by this 2% increases. So 5 divided by 1.05 further divided by 1.1. So the original price was 4.33. So you can do this division again on the on-screen calculator. So in this way, if we know the new quantity after a certain percent increase, we can find the original quantity easily by using this technique. So the next is related to find the original quantity in case of percent decrease. So if the quantity is decreased by some t% and we know the new quantity, to get the original quantity, we divide the new quantity by 1 minus t over 100. For example, the price of a short after a 10% discount is $500. So we know the new quantity and we know that there is a 10% deduction. So to know the original quantity, we divided 500 by 1 minus 10 divided by 100, which is 0.9. So this is $555.55. So this can be extended to multiple reductions. For example, a car was bought at $10,000. So this is the quantity after reduction, new quantity, that had an offer of 20% coupon off. Means there was a 20% discount by using the coupon code and a 10% further discount. So there are two reductions. What was the original price of the car? So now to know the original price of the car, we divide this new quantity by 0.8. So this 0.8 has been put here from the formula 1 minus 20 divided by 100, and this 0.9 has been put from the formula 1 minus 10 divided by 100. So again, you can do this work, this division work on the on-screen calculator, and the price, the original price we find is $11,250. So key idea 4. So this relates about multiple percent increases. We use the same logic here. In case of multiple percent increases, we multiply the original quantity by 1 plus percent increase over 100. For example, the gas bill increased by first 20% and then 30%. So the final price will be 1200 into 20% increase means 1.2 into multiplied by 30% increase is 1.3, which is $1872. The next example is 10% service charge levied on $40 item and then 13% tax imposed. So the new price will be $40 into 10% service charge means multiplied by 1.1 and 13% tax is multiplied by 1.13. So the final price will be $49.72. So this can be extended to any number of percent increases. Key idea 5. This relates to the multiple percent reductions. Here also same logic. For example, gas price fell by 20% first in January and then 40% in February. So now the final price will be 120, which is the original price, into 0.8. So this 0.8 has been put here from the logic. 1 minus percent reduction over 100, and this 0.6 has been put here by the same logic. 1 minus 40% reduction over 100. So the new price will be $57.6. And this idea can be extended to any number of percent reductions further. Now we move to key idea 6. So it says that order does not matter in successive increases or successive decreases. A% increase followed by B% increase is always equal to B% increase followed by A% increase. For example, 500 increased by 20%, then increased by 50% is always equal to 500 first increased by 50%, then increased by 20%. The next one is A% reduction followed by B% reduction is always equal to B% reduction followed by A% reduction. For example, 500 first reduced by 20% and then reduced by 40% is equal to 800 first reduced by 40% and then reduced by 20%. And this can also be extended to any number of further reductions. Now we move to key idea 7. The order of increase or decrease doesn't matter. So for example, A% increase followed by B% decrease. A% increase followed by B% decrease is always equal to B% decrease followed by A% increase. Means the order in which A and B appear doesn't matter. So we can use this to solve the problem like this. So discount first or service charge first. So whichever is first doesn't matter here. For example, the price of a certain item is $500. It is first discounted by 20%, and then service charge by 20% is added, and here service charge is first added and a discount is given, so this will be same. So it doesn't matter whether you increase the quantity by A% and then decrease the quantity by B%, or you decrease the quantity by B% and then increase the quantity by A%. So a quantitative comparison question. The price of a coffee is X dollars. Quantity A is price when the price a 10% discount, sorry, this is a typo, a price when a 10% discount is followed by 20% service charge. So first 10% discount and 20% service charge. 10% down, 20% up. So quantity B, 20% up, 10% down. So the order does not matter, 20% off in the beginning, 20% off in the end. So the answer must be C. So key idea 8. So this relates to the case of successive increase which is greater than a single increase. So this relates to, for example, a single increase of A plus B% is always smaller than the increase of A% followed by B%. For example, if you increase 100 by 40%, this is 20 plus 20, 40%. If you increase 100 by a single 40%, it will be 140. But if you increase 100 first by 20%, then by 20%, this quantity will be greater. So a single increase of 40% is always smaller than successive 2 increases by 20%. So this is always smaller. So now one example. Anne's salary is K dollars. Quantity A is her salary when the salary is increased by 30%. Quantity B, sorry, this is a typo. Quantity B, her salary when it is increased first by 10%, then followed by 20%. So in this case, a single increase of 30% will be smaller than the successive increase first by 10% and then 20%. So in this case, her salary will be greater in this case, and our answer is B. So now we move to next key idea 9. So just in case of increase, in case of reduction also the idea is similar. So a single reduction of A plus B% is always greater. Now in this case, always greater than a reduction of A% followed by B%. So for example, we reduce 100 by a single 40% and we get 60. Now we reduce 100 by first 20% and then again by 20%, and we get 64. So in this case, the single reduction reduces the amount by larger number. So here 100 is reduced by 40, here 100 is reduced by less than 40, 36 only. So thus a single reduction is always greater. In case of increase, a single increase is always smaller, whereas in case of reduction, a single reduction is always greater. Now we move to key idea 10. It says that if a quantity is increased by A% and then reduced by the same A%, we can never get the original quantity. So for example, if we increase 100 by 20% first, increase by 20%, and then reduced by 20%. So we won't be back to 100, we'll be back to 96. So the new quantity is always smaller than the original quantity. The new quantity is always smaller than the original quantity. The same case, if a quantity is first decreased by A% and then increased by the same A%, again the original quantity cannot be regained. So in this case, we first reduce 100 by 20%, then increase the amount by 20%, again we will be at 96. So in this case, the new quantity is again smaller than the original quantity. So thank you for watching this video. In the next two videos, I will discuss about the simple and medium level or GRE problems regarding percentages, and in another video I will be discussing the harder problem. Please do not forget to subscribe my channel, and thank you.